Law of constant proportion. In previous lecture, we have studied about law of conservation of mass that was proposed by Lavoisier. This law of constant proportion was proposed by Proust. This law of constant proportion is actually a mixture of two concepts. One is definition of a compound and another is its source. So combination of these two results law of constant proportion. So first we have to know about the compound. What is the definition of compound? When two or more than two elements combine in a definite proportion, definite constant, definite proportion by mass, there results a compound. There results a compound that has a fixed chemical formula. So what is a compound? A compound is obtained as a result of combination of two or more than two elements of identical or unidentical types in a definite proportion, and the compound form has the molecules and chemical formula of the molecules will be identical for a particular type of compound. Now next part of this law is the source. So Proust explains that as per the definition of compound, the composition by mass will be fixed, definite, and it will never depend on the source from where it is obtained. It will never depend on the source from which the compound is obtained. So what is the law? A compound is obtained as a result of definite proportion of two or more than two components, and its chemical composition never depends on the source from where it is obtained or irrespective of the source. Irrespective of the source. What it means? Means it never depends on the source. So let's take one real example, and under experimental justification we can understood about the law of constant proportion. Suppose in one experiment carbon coke is oxidized completely. Carbon is oxidized completely, that is the reaction is combustion. Under combustion it gives CO2 a gas. In next experiment, like calcium carbonate, limestone, this is alkaline earth metals carbonate. Under thermal decomposition, when heated, under thermal decomposition, it gives CO with elimination of CO2. Again CO2 is formed. In next experiment, now bicarbonates of alkali metals like sodium, potassium, etc. under heating, that is thermal decomposition, results carbonates of that metals with H2O plus CO2. You have seen that in all the experiments in three different chemical changes CO2 is obtained. If we see in first one, carbon ratio to oxygen, since we know carbon has atomic number 12 and oxygen has atomic number 16, so it becomes 12 ratio 32. Here it becomes 12 ratio 32, and here it also becomes 12 ratio 32. In simple form we can note down it 3 ratio 8, 3 ratio 8 and 3 ratio 8. So when carbon and oxygen combined by mass of 3:8, then carbon dioxide will be formed. Its chemical composition will never depends on the type of the sources from where it is obtained. Means if a compound is obtained from different sources under different chemical reactions, its chemical composition will never change. It will identical. It will be the same. So, law of constant proportion, I repeat it, it was proposed by Proust under experimental justification. Proust explains that when a compound is obtained, its chemical composition will be same. It never depends on the type of the source from where it is obtained, or in more simple form, we can say irrespective of the sources from where a compound is obtained, its chemical composition will never change, it will be constant. This is the law of constant proportion. This law of constant proportion has certain limitations. What are the limitations of this law? Limitations. First one is isotopes. You know about the isotopes. Isotopes of an element have identical atomic number but different atomic masses. Identical atomic numbers but different atomic masses. So isotopes doesn't follow law of constant proportion. If we find out CO2, in first one 12 isotope is taken, in second one 13 is taken, and in third one 14 is taken, then CO2 forms ratio will be in first one 12:32 in first one. In second one it will be 13:32, and in third one it will be 14:32. Since by mass the ratio get changed in all the three types of carbon dioxide, because here in this CO2 in different experiments different isotopes of carbon has been taken, and they are C12, C13, C14. Since their atomic masses are different, that's why their ratio by mass will be different. So isotopes will not follow the law of constant proportion. Next is isomers. In class 12, you will study in details about the isomers. What are isomers? Certain compounds that have same molecular formula, identical molecular formula, but different structural formula are called isomers. They may contain different functional groups also, like C3H6O. This is a molecular formula, journal formula. This journal formula gives three compounds. One is CH3, CH2, CHO. Next is CH3, CO, CH3, and last is CH2, double bond CH, CH2OH. These all three compounds contain same composition in definite proportion. 3 carbons, 6 hydrogen and 1 oxygen in each belongs to C3H6O. C3H6O. This will be also C3H6O. Ratio of carbon hydrogen will be same. 3 carbons, 6 hydrogen, 1 oxygen. 3 carbons, 6 hydrogen, 1 oxygen. 3 carbons, 6 hydrogen, 1 oxygen. Therefore, 3 into 12 ratio 6 multiplied by 1 ratio 16. So 36 ratio 6 ratio 16. Therefore, 18 ratio 3 ratio
8. By mass, this ratio of carbon, hydrogen, and oxygen will be present in all the three compounds since molecular formula is same, but functional groups are different with different chemical properties. It means when carbon, hydrogen, and oxygen will combine in a fixed ratio, in the case of isomers, identical types of compound will not obtain. Their chemical properties will be different. This is aldehyde. Its name is propanol. This is ketone. This is commonly called acetone, and its IUPAC name will be propanone. Propanone. This is unsaturated alcohol. Pro in IPAC nomenclature. You may visit the channel and see the lectures there uploaded already. Pro to enol. This is pro to enol. In all the three compounds, three different functional groups are present with different chemical properties. Although their component elements are present in the same ratio by mass, in spite of all these, the molecules are different with different properties. So isomers, like the isotopes, will not follow law of constant proportion. So this is all about for law of constant proportion. In next, we will continue about law of multiple proportion. Thank you.